everyone. Alright, so in this video, I'm going to teach you limit laws. And so let's write them all out. So let's start off with the sum law. So the sum law, oh, that was ugly. Okay. The sum law states if the limit as x approaches c of f of x plus g of x, you can break this down into two limits. So it's a limit as x approaches c of f of x plus the limit as x approaches c of g of x. Pretty simple. All right, moving along, we have the constant multiple law. This one states that if you have the limit as x approaches c of k times a function, you can have the constant outside the limit. So k times the limit of x approaches c of f of x. Okay, moving on, I'm going to do next the product law. Okay, so the product law is the limit as x approaches c of f of x times g of x. And so this can be written as the limit. Let me put parentheses. Put brackets. Okay, the limit as x approaches c of f of x times the limit as x approaches c of g of x. So this could be broken down into a product of two limits. And so, do I have room? No, I'll just go down. Okay. Next up is the powers and root law. Line. Okay. So, in this law, we're going to have the limit as x approaches c of a function f of x. I'm going to put p and q. And so, you can rewrite this as the limit as x approaches c, oops, that's supposed to be an arrow, of f of x, and the exponent can be applied after the limit is taken. Okay. Next up, the quotient. Yeah, I spelled that right. Okay. Quotient law. Did I spell that right? Yeah, I did. Okay. So the limit as x approaches c of f of x over g of x, this equals the limit as x approaches c of f of x divided by the limit as x approaches c of g of x. And lastly, we have the constant function rule. Ooh, that was an ugly C. Okay. Constant function rule, which states the limit of any function. So let's say limit as x approaches c of a constant k. That's just going to equal k. All right. So those are your laws. Let me zoom out for a bit. And let's do an example using them. Okay. So zoom back in because I write big. Okay. Example. Let's find the limit as t approaches 3 of this function t to the negative 1/4 times t plus 5, 1/3. Okay. Starting off, I can see this is a product of two functions, so I'm going to break it up. Limit of t to the 3 of t minus 1/4 times the limit of t to, is it positive 3? Yeah, positive 3 of t plus 5 to the 1/3. So the first one is simple. It's 3 to the negative negative 1/4. And the second one, however, the exponent of 1/3 makes things a little more complicated. But I'm going to take it out of the limit. And exponent of 1/3 is just the cube root. So I'm going to do the cube root of the limit as t approaches 3 of t plus 5. And so that makes it easier. So that's 3 minus 1/4. The limit as t approaches 3 of this function is 8. So this becomes the cube root of 8. So this is 3 to the minus 1/4 times 2. And if I want to simplify it more, I could just put it as 2 over 3 to the 1/4 to get, because it's a negative exponent. And so that's my limit. Okay, let's do one more example. Okay. Example. Sorry, I thought I need to sneeze. Okay, the limit as t approaches 1 of t plus 6 all over 2t 4. So, first off, I can apply the quotient rule. The limit as t approaches 1 of the numerator all over limit as t approaches 1 of the denominator. Okay. So, I can simplify the bottom a little more to make it easier to calculate the limit. Well, I could also do it to the top. I'm going to split it up as t approaches 1 of 6 all over. I'm going to take out the constant outside the limit. T approaches 1. And I'm going to take the exponent out also. Yeah, so it looks a lot more simpler. So then this would be 1 plus 6 all over 2 times 1 to the 4th. That ends up being 7 over 2. Yeah, that's pretty simple. Yep, so that's it for the limit laws. Thanks for watching.